Yeah.
It's the 7th of May. Erez and I are here talking mesh, but in a little bit of an indirect way. And I was just going to share a little bit about Asteria first. Let's grab this guy, make this a little bigger just for a minute and zoom in on this. So, what's Asteria? It's from TX Pipe, and it's a game designed to help people understand the EUTXO model. And the idea is that you get a spaceship that's represented by a token, and the position of the spaceship, you can almost compare this, like you ever play Battleship?
Yeah. Yeah.
You
It
got
kind
like
of
a
looks like that.
two by
Yeah.
two grid right here, right? And the position of the ship is stored as XY coordinates in the datum. Additionally, the fuel the ship holds is held in the datum. So it costs fuel to move around this grid. And the goal of a ship is to get to the pot in the center of the game board. So you can imagine that there's parameters. This is all built on smart contracts. The size of this board is a parameter, and we can say that the ship has to start some arbitrary distance from the center, right? And the farther away the ship is, the longer it has to travel, and therefore the more challenging the game might be to a player. Now, it's not just about moving the ship, it's also about having enough fuel to get to the center. So here's an example of a ship moving from X1, Y1 to X2, Y2. And that would actually include two movements, right? You can, whether it doesn't matter what order, up and over and up, but you're moving two squares, one, two, to get to here. And that's going to consume a certain amount of fuel to go that far, right? And so you have to stop at these little green fuel pellets along your journey. Otherwise, your ship will run out of fuel before you have a chance to get to the center. And there's a set of smart contracts that allow us to orchestrate this. And this is what TX Pipe built. They built it all in Aiken. And so you can see a couple of different validators here. Space-time is really where the game happens. This is the validator of all of the ship stuff. So you can see the datum here is a ship datum that has fuel, position, has X and Y coordinate, the name of the ship, and the name of the pilot. And that's what's going to be changed depending on the redeemer. And there's a few ways you can see what the redeemer is. One way is right here in the source code. Okay? What could the action be? Well, the action could be to move the ship a certain amount or to gather fuel or to arrive at the center and mine Asteria to win the game or to quit. Those are the four things a player can do: move, fuel, win, or quit. And each of them is going to involve a different change to the datum. So here we can see that if the ship is moving, the redeemer specifies how much, change in X, change in Y, and the datum gets updated, right? The X position plus the change, the Y position plus the change. Everything else has to stay the same. If you're gathering fuel, position changes or sorry, position stays the same, but the amount of fuel changes. And so what we thought we would do is take these contracts. Sebastian, hey,
Hey guys.
what's up, man? And Chris is just, hey, Chris. I was just catching errors up on what we talked about last week, but this is where we left off, as we said, okay, well, the Asteria repo comes with some ready to go um, off-chain code. And the off-chain code here is written in Lucid. And so we thought, well, what if we take these contracts and we try to build similar transactions, but for mesh? And we could start with these three transactions, start a game, mint a ship and a pilot, and just start playing with moving the ship. So not even worrying about all the redeemers of the space-time contract, but just starting with this one. If we could get some tokens minted, we could start moving them around the board, then we could think about a little UI for this. It'd be fun to check out like a game engine and see if we can do a little simple visual of this. Yeah, so Eris, what do you think?
Yeah, it looks really cool. I've had a difficult time kind of uh, understanding how datum and state are related, but it seems like with this example that it's a really good example of how the state changes with the datum with every player move and everything. Is that correct?
That's exactly it. And that's I think the best way to understand what datum is. Right? It allows us to put a changeable state on chain. And one of the most exciting things about datum is that in our validators, we can write very precise rules for how that state can be changed, right? If I'm moving the ship, I can only make a targeted change to the X and Y coordinates, right? But I can't change the amount of fuel. On the other hand, if I'm gathering fuel, I can change the amount of fuel, but I can't change the position, right? And both of those represent the state of my ship. And I think that does generalize, right? Any validator you can look at, it's safe to think about datum as state of some sort. So how does that relate to Redeemer? Redeemer isn't state, but it's a way of sharing what your intention is. All right. So Redeemer, what's my intention? Whoops, my screen share just stopped. Here we go. Right. Datum is my state. Redeemer is the intention for what I want to do. What's my intention? It's to move the ship. Okay, well, if your intention is to move the ship, then you have to provide delta X, delta Y. How much do you intend to move the ship? And if your intention is to gather fuel, okay, how much? How much do you intend to gather? So yeah, this is a state and this is an intention of action. Now, the other thing we have here is a parameterized validator. So if you're familiar at all with Plutus TX, you're probably familiar with this structure right here. When we're creating a spending validator always has datum redeemer and then the script context, or I think it's good to remember this is the transaction context, right? What is the transaction in which this validator is being called? So that's all well and good. In Plutus, or I should say in Plutus TX, when you have parameters, you might be used to them showing up like right here, right? Parameters. And we could give those a name, right? Space, time, params. The Plutus code would look a little bit more like this. Obviously, it's not calling these as arguments to a function in exactly the same way. The syntax of Haskell is different, but this is not even how you do it in Aiken. In Aiken, parameters go here. Okay, so we say we're going to make a validator. If it didn't have parameters, it would just look like this, right? So this would be a validator with no parameters. But most contracts are going to be reused many times. And this is a great example of that. We want to be able to create different instances of an Asteria game. Compare this to just any mobile game you've ever played, any video game you've ever played, right? It consists of a set of levels. And so each level of a game you could imagine being an instance of this validator. And what are the parameters here for a given instance? Well, there's some stuff we just need to know, right? Some other validators. This game consists of several different validators all working together. It's got the pellet validator, and we can look at the on-chain code for that. On-chain, source, validators. All right, so here's a pellet validator. We'll look at this more in just a minute, but it looks like this. We also need the Asteria validator. That looks like this. And we'll look more at what this does in just a minute as well. But all of these things, these are kind of the on-chain parameters, right? Okay, I got to tell it which other contracts to connect to. I got to provide a token that serves as an admin token that lets somebody administer this game. But these are the really, these are the params right here that let us think about the game and many different levels or instances. Max moving distance, how far can a ship move in one transaction, right? Max fuel, how much fuel can a ship hold, right? Fuel per step, how much fuel do I spend to move one square on the grid? How much fuel do I start with? And then this one, the min Asteria distance, that refers to how far from the center a ship is going to start. So can you start to imagine how changing these are just integers, right? 5 numbers, changing these 5 numbers would result in easier or more difficult game boards. Does that make sense? And yeah, on-chain, I'm reading the question in the chat. Does on-chain validator mean that anyone can access it if they know the script address? Yeah, that's exactly right, right? Anytime you write validator code, that code is public. Well, yeah, it is. I mean, you don't have to open source your code, I guess, right? So you don't have to publicize the code, but once it's on chain, anybody can look at the seaboard, right? And you're going to create an address. You're going to put tokens there. Now that it's on chain, anybody can look at that address. Anybody can see what's stored at that address. But the rules dictate who can do something about it, right? And you need certain tokens to be able to play around with this game. And
Hey
so
James,
that's,
sorry to interrupt. Is it possible to zoom in a little or
yep,
make the text a bit bigger? Thanks.
yep. So an example of who can interact with this thing, who gets to move a given ship. That would be the pilot, right? And the pilot is represented by a pilot token. The pilot token goes in the player's wallet. The ship token, right, goes at the validator address. Which validator? The space-time validator. So when we mint tokens, and going back to what we left off with last week, right? When we mint tokens, a player must be able to mint both a ship and a pilot token pair. Because in the validator, in order to, let's find it here. So, right, the datum has a ship token name and a pilot token name. And before we even look at what the player wants to do, right, the redeemer, remember, is where I say what my intention is. My intention is to move the ship. But in order to do anything here, look what has to happen first. Must hold ship token. Right? The input has to have the corresponding policy, whatever policy we used in the parameters when we compiled this, and the name of the ship token. And then we can see, all right, there must be some pilot token here. But where do we see somewhere the pilot token name has to match the ship token name? Where is that? Distance, fuel. Okay, no, we don't need to check. We're not checking that the okay. Yeah, we're not even concerned about directly checking if the ship token name matches the pilot token name because they're both in the datum. Okay, so when the ship datum is created, we're able to say, okay, here's the name of this, here's the name of that. And then to move this ship, we just have to confirm that pilot token name. This is just a destructured datum right here. So pilot token name from the ship datum must be the name of the token in some input UTXO. And the util is provided right here. Is pilot token in UTXO? Jump over to utils. So this is just checking that given some UTXO with some policy ID, this name is in the list of tokens for that UTXO. So get all the names of tokens in this UTXO with a specified policy ID, and then confirm that at least one of those token names, right? At least one of those token names matches the pilot token name. Otherwise, you can't play. You don't have the right token to update this datum. Yeah, Chris, what do you think?
Hi, James. No, I was about to ask you about the reason of the name on the ship and the pilot, but you already answered the question.
Oh, awesome.
So,
Yeah, I'm learning this myself as we go. It's exciting to just be here kind of breaking this down in real time.
yes.
All right, so here's the first difference we have to look at here. All right, and this gives us a chance really to look at Aiken a bit. Um, the way this repo is built is we might have, for example, this parameterized validator, right? We already read through this list of parameters on the space-time validator. And forgive me if I'm going too far down the rabbit hole, but I think it's worth it just to think about this. In prior Plutus PBL courses and in a lot of the work we've done with Plutus TX around here, we've demonstrated how to build parameterized contracts using Plutus TX. And maybe it's worth looking at a quick example of this. Let me pull this up for just a second. Here's an example from the new Plutus PBL course. This is the faucet validator. So just to remember what this looks like, or if you haven't seen this before, this is what I was just describing, right? So this is Plutus TX, datum, redeemer, and context, just like in Aiken, but the syntax for Haskell is a little different, right? But it's the same idea. In this case, the parameters go here. And where are they applied? Well, there's a lot of different ways to do it, but one of the ways that we show people to do it is just by separating some different functions into different files. And so we might have a faucet validator right here, faucet validator. And then we can make a separate compiler file for this and look at these params, faucet params. Where are those used? In the validator, faucet params. And what are they? Two currency symbols. Currency symbol of some access token right here, and of some faucet token right here. And this is the token that any student can mint. This is just a native asset on pre-prod that people can get from a faucet that's live right now. But the key thing I want you to know here is that this is where we apply the specific parameters, this particular currency symbol and this particular currency symbol that allows us to compile a custom instance of this smart contract. And that leads to having a particular address. I could compile this with a different currency symbol, and I would get a slightly different compiled script, and I would get a different validator address. That's what parameters allow us to do. Many different addresses with the same business logic. So how is this done in Aiken? Look here. In this project repo, the parameters are actually applied not in the Aiken code, but in some off-chain code, on-chain, off-chain, that's written with Lucid. Let's see what that looks like. Okay, so here is Just looking at this. Okay, so here's an example. Yeah. All right, so this is constants.ts. This is a TypeScript file that is importing a custom type from this project. And in this case, just one lucid function from text. What it's doing, and I'm assuming, yeah, this probably this converts a string to a hex string. And this just, now we have a name. A name of what? Of an admin token with a particular policy ID. And this admin token here, remember, is a parameter of the space-time validator. There it is. And Lucid is actually doing the work for us of compiling the specific instance of the validator. Here, you can see we're providing a bunch of other parameters. These are the integer values that allow us to customize the game. How much does it cost to mint a ship? How far can a ship move in one turn? This has 5 squares. What's the max amount of fuel the ship can hold? Okay, 30. A cost of 1 fuel per step. Initial fuel, we're going to give the player a full tank of gas. There it is. That doesn't have to be the case, but here it is. And we're going to start players at least 50 squares from the center. Once again, these numbers can be changed. Any questions about this bit? Space-time pulls in a validator. We'll talk more about the blueprint in just a second. This is really important. Where is the compilation step happening? All right. Okay. So Lucid comes with a function, apply params to script. Excellent. And we do have some compiled validator code. It gets placed in this Plutus JSON file, also known as the blueprint file. And there's a lot more we're going to do with these files over the next few weeks. I think there's some really exciting work happening right here. But I don't want to get distracted by all of those details yet. We're going to get there. But what I want you to see about this file is it gives us a list of validators. For example, the spending validator. Here's the deploy spending validator, the pellet spending validator, the space-time spending validator, space-time minter. And that's good. And then we have a bunch of definitions. Okay, the definitions, there's a lot of them. We're going to see more about how those work. But let's just look at each of these validators at a high level. What does a validator have? Well, it has a datum type. This is defined down below. A redeemer type that's defined in those different definitions below. And a list of parameters that can be applied to this compiled code. This is a long string right here. Right? So this is the compiled code, but I think it's helpful to understand this as partially compiled. It doesn't yet have, well, it's completely compiled, but it's not yet going to work because it doesn't yet have the parameters applied to it. And so if we think about the space-time validator, I think that was down here, a space-time minter, that has some parameters too. Space-time spend, there it is, right? With all of these parameters, all of this customization gets applied to this compiled code, right? There's your space-time validator in CBOR. And how are these parameters applied? Here's how. We pull in from the blueprint file, which comes from this file right here, which we were just looking at. That's the plutus.json. See, okay, import that Plutus blueprint. Find the one with this title, spacetime.spend. Oh, there it is, title, spacetime.spend. Right, find that one. Okay, now we have a spacetime validator. If you don't find that validator, throw an error. But as long as you do find it, now we say, okay, here's our script. It's the script part of this new spending validator record that we just pulled in here. Okay. So which part are we looking for? We're looking for here, the script. Okay, it says this is called compiled code. So where do we see that, right? The script, spending the validator script is equal to the spacetime validator dot compiled code. This thing and this part, compiled code. Oops. So now we have a spacetime script. And then we say, okay, let's pull in some parameters for that. And then let's apply those to what? To the spacetime script right here. All right, but where are those values coming from? They're input here. So now we have a function. We define the data type, but not the values. So this data bytes. Here's one validator address, second validator address, asset class, that's the admin token, and then 5 integers, these. But we're not going to see the values that are being applied until we find where this function is actually being called. Let's copy this and search for it. Right, here's the source code we're looking at in the spacetime validator. Let's go look at deploy spacetime. It calls build spacetime validator here with all of these parameters. Right, so where are those defined? The script address is derived from palette address dot hash. All right, so here's another Lucid function. Asteria address, same thing, right? This right here is the same as this right here. Where's the admin token coming in? Okay, the rest of these variables are being provided as parameters now to this function. Okay, deploy spacetime is wrapping the rest of this. So now we got to look for where is deploy spacetime called. Let's do the same thing, find that. We are in off-chain source code here. And then we're using it here. And so all this says is, okay, run this deploy spacetime function that actually doesn't just gather the parameters, it also builds the transaction to create this new game instance. Okay. And that's why we have a pretty short file right here. What do we have? All we're going to do is we're going to build this transaction, deploy spacetime. Now with each of these variables, where are those variables coming from? They're being imported from this constants file that we were looking at a few minutes ago. Now we've come full circle back to here. Okay, so parameters are provided. So we're kind of tracing one pathway through an off-chain code base. And in this case, it's one that is built with Lucid. And we can see how this works.
Hey James, I'm really sorry. I'm just really glad that you're going through and showing us where everything is coming from. It's really easy as a student to get lost in that and to not know where things are being imported and exported from. So it's really helpful. Thanks.
Yeah, man. Oh, I'm really glad to hear that. Yeah. This is, I hope this is a process that you can like try on your own for other sorts of contracts. All right, so here's where it gets interesting. Mesh doesn't quite yet provide this ability to apply parameters to a contract. They're working on it and very excited about it, but we don't have it yet. And that's okay. This gives us a chance to learn more about how Aiken works and which of these features do exist when we start to build transactions. So let me go back to here. This is the one where we build that. Here, this one, right? So this is the one that ends with a transaction. And actually the transaction part, this is the easy part. Once we have a compiled validator, actually the mesh transaction is going to look pretty similar to this. We'll compare it when we get there, but we're not there yet. We can count on mesh for this part, building the transaction, paying to a contract at a certain address with certain datum and a certain amount of tokens. But we need to compile the Aiken contract with parameters applied to it over here, just so we can play with this. And this is going to come in handy in the PPBL course when we get into a couple of Aiken lessons starting next week. So let's take a look at the Aiken documentation. On my screen is just a repo running locally where we're going to build this demo. There's nothing here yet, but it's initialized as a T3 app and we can start building into it. We'll look at that at the end of this session. But let's take a quick look at filing contract. So this is a validator without any parameters, just datum, redeemer, and context. But you can see right here, no parameters are applied to it. Gift card. This one has parameters. This is a minting transaction, so it only has redeemer and context, but we don't need datum in a minting transaction. And you can see an example of these being applied. It's walking us through just all of the validator logic. That's fine. And this guides us into building some front end. And it shows us how to apply parameters the same way we were just looking at it in the Asteria code base. All right, that's all well and good. But what if I want to apply parameters in the on-chain code? It shows us how to apply parameters. But what if I don't want to do it with Lucid? Just play with it a little bit. Let's just play with it. Just not sure exactly what the pattern is. Let's try something here.
What are you trying to do right now?
I'm trying to learn how to apply these parameters directly in Aiken instead of compiling Cbor without the parameters and then using Lucid to apply them. I would like to be able to use an Aiken project natively as the generator. And there is a function for this. And I'm trying to learn just enough syntax to know how that works. So this is something, we're not going to have time to take this to the end today. But I think we're set up for those next steps. So I need to learn syntax. Validator.
Is that an AI pilot kind of thing that's kind of helping to predict what you want to do?
Do I have something installed on this? Sorry, I wasn't paying attention. I didn't notice it. I forget if I have Copilot installed here. I was playing around with it at some point.
Yeah, I've heard it's a great tool. That's why I'm asking.
I don't think I put it on this computer, but there's a lot of autocomplete, yeah, built in, and sometimes I'm not sure what's enabled here. All right, so that's the next step. So this is done. It's live. We're going to save this for next week. So that's the next step. I really want to understand how this works because we need to know it for PPBL anyway. I think a few other people have been working on it, so I'll ask Hinson and Alex for help on that too. And then drop by the TX pipe server just to make sure there's an example of this. Yeah, we'll take it from there. So this guy right here, this is the Mesh Asteria demo app repo. There's really nothing here yet, but our dependencies are installed. This README is up to date. So let me add this. Initialize T3 app, install dependencies. of the README on 7 May. Push that up. And this is, you can find this repo here. Let's refresh. So that's here. This is live and public. It's really just kind of the same template that's being used for the PPBL 2024 demo site. But if anybody needs this, you can take a look. And we'll continue to now start building these transactions next week. But I needed that time to kind of look through and understand that there isn't a live example yet for parameterized validators. So eager to learn that pattern or find out who's published something about that. Then we'll compile these things. And then with compiled contracts, we'll jump straight into then building these first 2 transactions, starting the game, minting the tokens, and then we could start playing with them. But thanks. I'm excited about using this time for live sessions like this, just really an honest look at where we're at. And if anybody else has a concept that you'd like to just work through live, just let me know anytime. Would love to let somebody else drive. Good for today.
Thank you so much.
Yeah. All right. See you soon, everybody.
Take care.
Thank you, James.